Hi everyone. So welcome to the second recording of this lesson. In the first recording, we were talking about environmental management accounting tools and techniques for water. So we finished accounting for water aspect in the recording one, and then we are going to start discussing other environmental management accounting tools you can use in this corporate sustainability aspect. So let's begin with other EMA tools. Right. Now, as you can see, life cycle terminology coming under this EMA tools, other EMA tools, we will be first discussing life cycle, life cycle analysis. So there are different terms, terminologies used in this life cycle aspect. As you can see, LCD stands for life cycle design, and then life cycle assessment or life cycle analysis, LCA. And then the third one is LCCA, that is life cycle cost assessment. That is more towards accounting part. We are analyzing the costing of this life cycle, and then life cycle accounting. So these are the different terminologies used in this life cycle analysis aspect. So the explanations, definitions, or the descriptions for each and every terminology has been given in this table. Now, what do you mean by basically life cycle design? You have actually learned this in your second year. Can you remember when it comes to management accounting, we were talking about this life cycle analysis. Now, if I show you this diagram, what is this? Usually, we show this diagram, we explain this as a circular economy. Circular economy. Usually, what happens is we are taking natural resources from the natural environment, we extract the resources, that is the input, and then we have the process in the organization, and then there are outputs. Outputs can be product outputs or non-product outputs, as we discussed in the previous week. So product output means the good output, or it can be waste, right? Sometimes we are throwing the waste away to the, we are adding that environmental like waste to the environment, or we are using incineration, or we are landfilling. Likewise, there are different input process, output process. This is not circular economy, this is linear economy. It is like a one line input, process, and output. In that economy, it's a linear economy. But circular economy means what? As you can see, we are extracting natural resources like this, extract, and then we are designing and we are doing the production, we are packing, we are distributing, and then customers are using it, maintaining it. And sometimes what happens is basically disposal at the end. Let's take a plastic bottle. After using it, we are throwing it away, that is the disposal. But if it is a circular economy, in the circular economy concept, it says we can add this back, disposal, to the circle again, production circle again. Now, rather than just incinerating or landfilling the plastic components, if we can recover them to the production process back, if we can recycle the materials and components used in this product, or if we can reuse these things, then those things are added back to the economy. That's how that linear economy like this has become a circular economy like this, right? So you have learned this, that aspect previously. Now, what is this life cycle design then? Life cycle design means you have to design your product, you have to design your service in an environmental friendly manner in the design stage. Can you remember we discussed this is also another concept. 80% of your product cost, 80% of your product cost have been designed and committed in the designing stage itself. Now, when you are buying a vehicle, there are different vehicle types. Now, some vehicles are like fuel efficient. Some are not. Number of kilometers you can run with 1 liter of fuel, that depends with vehicle to vehicle. That means we call it fuel efficiency. Now, if you are buying a fuel efficient car, that you are committed for a low fuel cost in the long run, maybe for the next 4 to 5 years. You know that your fuel cost will be lower because you have bought a fuel efficient car. Let's say you are not buying a fuel efficient car, it's not a fuel efficient car at all. Then you are committed for a high fuel cost in the future for 4 to 5 years. Next 4 to 5 years, you will have to spend a high fuel cost because you have not purchased a fuel efficient car. So, likewise, designing is very important. In the design stage itself, you design everything. You commit the cost, right? You decide the cost. And later on, later stages, like when it comes to manufacturing, you are actually spending that cost. But when you go to manufacturing stage, you can't change or you can't control cost as such because everything has been decided in the design stage. So, what is the most important aspect? If you want to produce an environmental friendly product, rather than talking about how to recover, how to be environmental friendly and all after producing the product, if you can design an environmental friendly product at the first place, that would be the important thing. So that is why it says life cycle design. Approach for designing more ecologically and economically sustainable product systems by integrating environmental requirements into the earliest stages of the design. You have to bring these environmental aspects into the earlier stages of the design, not the manufacturing phase. And then life cycle analysis. So you can say life cycle assessment. What is that? When it comes to a product, you have to think about the whole life cycle. It can be from the research and development to introduction to growth to maturity to decline. Before you produce the product, before you manufacture the product, after manufacturing, after selling, and the consumption, you have to think about the whole life cycle of a product. So environmental aspects, positives or negatives related to linked to the whole life cycle should be captured. Holistic approach to identify environmental consequences through its entire life, not only the manufacturing phase. What happens after the end? What happens when you have used a plastic bottle, plastic water bottle, not only in the manufacturing process? After the consumption, also there are negative impacts on the environment. So that is life cycle. Whole life cycle should be considered. Life cycle analysis you call assessment. And then another terminology is life cycle cost assessment. That means basically accounting part. Emphasizes the costing aspect of life cycle assessment. Now, let's say you have identified different environmental impacts along the life cycle. Now you need to have the cost. You need to decide the cost. What is the cost at the end of the life cycle? Likewise, systematic process for evaluating LCC by identifying environmental consequences and assigning monetary values for those consequences. If there is a negative impact on the environment, if the materials, if the components should be collected back as a government rule because of the negative environmental impact it does after the consumption, it has a cost. Pre-collection, it will have a cost. So those are the monetary values of these environmental consequences. Life cycle accounting means assignment and analysis of product specific cost within a life cycle framework, including usual, hidden, liability, and less tangible cost. Basically, the accounting process. You have to take all these cost aspects into accounting. Let's say when you are calculating the unit cost of a product, environmental aspect like monetary values you have given for environmental consequences also should be added, also should be taken into consideration, right? So the next one is some examples for this life cycle design. Now this is one photograph taken from Hotel Sigiriya. Now if you can see here, There are no air conditioners or fans fixed in on the roof, right? Because at the design stage itself, they have designed this. This is the restaurant, if I'm not mistaken. In this restaurant there are no windows or anything, open space. So in that case this is a natural airflow, natural sunlight, natural air is coming, natural ventilation is there. So no need to switch on lights in the daytime because natural light is there. And then airflow, natural ventilation is there, so no need to switch on the fan, so putting ACs. So when you design the restaurant building in this kind of, in this manner, you are committed for a lower electricity cost for this restaurant, isn't it? So this is why in the design stage itself we need to think about those things, life cycle design. And this is another environmental friendly design. This is Hotel Kandalama. So Hotel Kandalama, if you have gone there or maybe you have read about it, uh, designed by Jeffrey Baba, famous architect. In that case, this hotel has been built on pillars. Forest, the jungle is there anyway, so hotel has been built with minimal damages to the environment. See, animals, air flows, natural ventilation, natural sunlight, everything is there. No need to switch on fans or ACs or anything. No need of lights in the daytime. You will have to switch on the lights only in the night time. So basically this is environmental friendly design. These pathways are built on the pillars, right? So that is one way. And Sumangala building. Now, if we take the Sumangala building, see that Madhamidula concept giving coolness to the entire building because of that pond in the Madhamidula. And also, if we take, now I have not added a picture, if we take Basha is a negative, like a bad example for this environmental friendly, or you call uh, this life cycle design. Basha is a bad example. Why? Now if you can, like, just imagine Basha building. Where is the main entrance? Main entrance is located opposite to the ground. Now, from the ground side, from the hostel side, natural airflow, natural ventilation is coming from that side. But the main entrance of Basha is located opposite to the natural ventilation. That is why we need so much of, no, we are not using ACs, no, we are using fans and all. Temperature is very high. That is why it is very hot inside Basha. They are not using the natural ventilation in that building because the entrance is opposite to the natural ventilation, that circle. So those are bad examples, I would say. But when it comes to Mangala building, it has thought about this Madhavitula concept, giving putting up ponds. This is not only for the beauty purposes, right? This is for, like, giving all these architectural aspects, natural needs for an environment, right? So in this case, uh, another important thing would be LEED certified buildings. Now, when we talk about these life cycle design, LEED certificate is that is called Leadership in Energy and Environmental Design. It is most widely used green building rating system in the world. Green buildings. Now, in Sri Lanka also there are some examples where they have taken, or available, they have taken this frame, they have built their buildings based on this framework, and they have taken this certification as well. One is MA's Fabric Park in Tulhiria. So as you can see, I have added some pictures. You can see how they have used that greenery concept when they are building the buildings. So that is a platinum certified one. And we have more examples. Pittipana Nanotechnology Center of Excellence. See, natural light is there. When they are building, when they are designing the building, they have used it. And then Brandix Essential Buildings at Kongala. It is a gold certified building. Greenery concept, natural ventilation, natural sunlight and all. So they have considered all these aspects. Now, when we talk about this, like greenery concept, life cycle design, and all, there are so many good examples from ancient Sri Lanka. Now, if we take ancient, not ancient, Sri Lankan Buddhist temples, right? So, what the peaceful mind it gives you when you are entering, not like temples in this rural area, not this area like urban areas. If you go to an actual temple, Buddhist temple, the peaceful that mind you get when you are enter into the temple and all, that is like good examples for these constructions. When you are doing these constructions, it gives you this peaceful mind, right? And then Sigiriya, how they have used the how they have constructed the water garden, that system, the peacefulness, the architecture, and all good examples. Sigiriya. And this is in Polonnaruwa Satmahal Prasadaya, palace of Parakramabahu king. So they have used, in order to keep the walls in a cool manner, they have done a system, water system. So see how they have used these things, right? And then this is Madhavasala in Kandy. That means palace of the queen. They have Madhamidula, and then their walls are very, like, they have, those walls are very unique because they are constructed in a way that heat is not coming inside the room, that temperature is very lower, a very cool environment they have created, right? Different methods they have used, and their tiles are also different, very cool tiles they have used. So those are the important things they have used in the ancient Sri Lanka, right? And then LCA steps, like life cycle assessment, life cycle analysis steps. Now, just look at the main points. There are four main activities. First of all, you are setting the goal, basis and scope of evaluation are defined, and then you are collecting data. That is, we call inventory analysis, collecting data. What are the inputs? And then quantifies energy, raw material inputs, air, water, and then the output, waste output associated with each phase in the product life cycle. Likewise, you are analyzing, you are collecting the data. And then you are evaluating environmentally, environmental evaluation. It can be emissions and consumptions are translated into environmental effects. And then finally, improvement assessment and interpretation. Now, this LCA, life cycle assessment, has been done in a very comprehensive way by Levi's as well. I will show you those things. Now, before going into detail, now in this one, LCA inventory analysis, it shows you the inputs, maybe you are putting energy or maybe you are putting raw materials and all. The process is happening. That means acquisition of the raw materials, and then you are manufacturing it, you are transporting it, you are using, reusing, maintaining, and then the waste management. And then what are the outputs? Sometimes water waste, solid waste, energy loss, byproducts, other releases, main product. Likewise, you are analyzing your life cycle, right? Now, this is the example I was taking. This is the LCA steps of a Levi's gene. Now, they have done a comprehensive analysis. Now, look at the circle from the cotton production. Starts with the cotton production because it is needed. Fabric production. From the cotton production, using the cotton, they are manufacturing fabric production. And then garment manufacturing, using the fabric, they are manufacturing the jeans. And then transporting, distributing, and then consumers are using the garment, jean, consumer care, or sometimes after using, it is the end of the life of a jean. They are just throwing it away, maybe landfilling or incineration. Most of the time, clothes are going for landfilling, end of life, or maybe you are recycling, and then that is again coming back to the process. So this is the life cycle of a Levi's jean. And now they have calculated the life cycle impact of this Levi's jean. Now, before coming to this, I will show you these things. What is the climate change impact of this Levi's jean? Consumer care phase dominates the climate change impact area. And then climate change impact percentages by phase. Now different phases are there, no? Fabric production, and then consumer care, transporting, logistics, and then cutting, sewing, finishing. That means the garment production. Likewise, there are different stages, no, in the life cycle. So they have given percentages of the climate change impact. As you can see in this diagram, which phase has the highest climate change impact? Consumer care, 37%. Why? When the consumer is purchasing a jean, washing it, ironing it, and then using it, again washing, ironing, using. Likewise, there's a now when we are purchasing a jean, we are not just using a jean for 1 month or 1 year, right? It will be there with us for years, I would say. So the frequency, how many times we will wash the jean. So how many times when we are washing jean, the water consumption, when we are washing, if we are using the washing machines, energy consumption. Likewise, there are so many things. If you are ironing by any chance, the energy consumption again. So there are different things. That is why the climate change impact is higher when it comes to the consumer care stage. But when it comes to fabric production also, there's a considerable percentage, 27%, right? What about this logistics and transport? Again, when the vehicles are moving, when the vehicles are going to be there with the distribution, 11% of climate change impact. So as you can see, as percentages, this is the consumer care one is the highest, and then the fabric is the second highest. Now, if I show you the water consumption over the life cycle of a gene, fiber production to 68%. Fiber production predominantly cotton, because when it comes to cotton farming, that consumes a lot of water. So in the water accounting recording also I mentioned that cotton farming. So predominantly cotton contributes a wider margin to water consumption. And then consumer care is the second one, because anyway the customers are washing the jean multiple times over the years, multiple times. How many times, right? So that is 23%. So 68% coming from fiber production, that is cotton farming, like this. And then this is on average, now I will upload that uh, results report of Levy's survey to the LMS. You can go through it if you are interested. Now they have done the survey in different regions as well. Asia and then America likewise. On average, Americans use more water and energy to wash their jeans. See, lifetime consumer use of non-renewable energy. China, UK, and France and US. US customers are using non-renewable energy the most. Lifetime consumer use of water intake in liters. See, US customers are using more water and energy to wash their jeans. So like this, they have done their analysis. This is a lifetime analysis, right? Not only one time. So what are the things you need to understand from this? Majority of the environmental impacts occur outside their control as well. Now, when the production is done, babies can say, our production is done, we have sold the gene, that's it. But we have to think about the other way around, right? We have to think about the consumer use as well. When we are using, when we have sold the product, consumers are using it, then there's a huge climate change impact, water impact, energy impact, likewise. So it is necessary to engage other parties also to the value chain. So that's why sometimes we can take necessary steps. We can create awareness among the customers. We can create different recycling methods, different things companies can do on behalf of this, right? Okay. And then environmental, the second one, life cycle analysis, life cycle costing is one environmental management accounting tool. With that, we are moving to the second method, environmental activity-based costing. Under this, if you can remember the conventional costing, basically the process costing. Now see, other overheads are there. Toxic waste of B, that means maybe negative environmental effect impacts of item B, right? Item B. And then what happens when you are allocating cost coming under conventional cost? You take all these overheads together, allocated overhead, and then uh, just allocate into item A and item B at the same time. We are not segregating whether this overhead, whether this toxic waste is related to item A or B. Conventional costing, just taking the overhead together and just allocating. But when it comes to the activity based costing, environmental activity based costing, the concept is if you have like monetary values given for negative environmental consequences, especially with regards to item B, that should be allocated to item B only. Otherwise, item A cost is overstated, right? Item B cost is understated. That's why if you can identify these environmental related cost specifically for a particular product, those should not be taken generally as general overheads to be allocated. Those should be considered for the product itself. That's why we need to directly allocate overheads using environmental activity-based costing. That is one. That is another EMA tool. Third EMA tool is environmental capital budgeting analysis. This is very important. No? Now, capital, we call it capex in organizations. Basically, capex means you are in the budgeting also, capex budget also, you are allocating money to purchase the relevant machines, furniture, equipment for your production. But when it comes to environmental friendly things, like some machines are required for environmental aspects. Let's say a solar project. Now, when it comes to a solar project, it should be taken positively. Like if we are using for capital budgeting analysis, if we are using NRV or payback period or any method, IRR or anything, if you just focus on financial ratios, financial factors, that the positive environmental effect it will create on the environment will not be captured. Sometimes to get the positive impacts, to get the positive environmental effects, it will take some years as well. So if you are just talking about the payback period, if you are taking the so under the payback period, you are taking the lowest payback period, project with the lowest payback period, right? Earlier the better. If you are going with those concepts, those methods, that positive environmental effects would not be captured. So that is why top managers, the parties who are responsible for these decisions should take the environmental aspects into consideration very seriously, right? One thing is, if it is related to a environmental friendly project, those things cannot be fully evaluated using financial factors. Those should be evaluated separately, differently. But at the same time, if you do not recognize these things, what will happen to the organization? Won't be able to survive. So that is why very important environmental aspects, non-financial aspects should be considered in capital budgeting analysis. So important to fully consider the environmental impacts as well. Now, if I just explain one example, let's say you are trying to create a sewage treatment plant in the organization. If you just calculate the financial benefits, there won't be any at the first time. But it will take some time. Over the years and years, it will give you the benefits. It will be environmental friendly as well. So those projects, if you look at those projects in a financial life, you won't approve those things. So that's why environmental capital budgeting analysis is important, right? And then integrating environmental accounting into capital budgeting. Basically, you need to quantify the environmental cost, allocate project environmental cost and benefits using appropriate both financial and non-financial indicators, not only financial, and then set reasonable time horizons that captures environmental benefits. That's why I told you to get the environmental benefits, it will take some time. But if you are just talking about 2 to 3 years, it won't give. But that's why reasonable time horizon should be kept to capture those environmental benefits, which will take some time. right? So those are the important things. So with that, we are ending life cycle, other EMA tools as well. We discussed life cycle costing, and then environmental activity based costing, and then environmental capital budgeting analysis. Right. Thank you.